Hello everyone. For this session, we will teach you how you can get the Hexa mesh for T junction with a thickness to be used as a solid for the heat transfer type of the simulations. So this is a solid case. You will find also with in the description where you can download the files unsolved and the solved case. So let's start with a very fresh start. So create a new block and call it fluid. Later we'll change the blocking to the solid also and save this project as a just a T junction solid. It's an unsolved case. Now display the surfaces also. Now make the three splits, one here, second just after the this vertical pipe, and one between the two pipes, vertical and horizontal pipes, where we have the interface. After that, delete the extra blocks, and the next thing you have to do is to associate the edges to the curves. So these should be associated to the outermost curves here, and similarly for these edges. Okay, also group the curves in a single curve so that you can have the ease in selecting only one curve when you're going to associate four or five edges. So because it's a circular part, so we have to select all the edges once and then all the curves once. So there's no point in selecting the 10, 12, 15 curves by just clicking on the different locations. So just group them in a single curve. So this will ease your process. Now go to the third end of the geometry and select the curve here. You can see now this is a single curve here. Now fix the blocking towards the corresponding geometry by selecting the association of vertex to the point. These points are already created on this geometry and they are at the 45 degrees and then 135 and then 270, sorry, 135 and it's a 45 plus 90. So second point is at 135, third point is at the 225 and the next point is at the 315. So these points will give us the perfect square. Once you have done this one, you have to again associate the vertex to the curve so that we don't have any over constraints on the blocking here. Similarly on the second side of the pipe, now again change the option to the curve, also over here, and then again associate them to the underlying curve here, and now adjust the blocking. Before that you must associate these four edges to this curve, which is very obvious if you look at the geometry. If you hide the two surfaces which are the solid pipe 1 and solid pipe 2, it's pretty obvious that this is the curve where the solid is turning from vertical to the horizontal pipe, and this is a location where we need to put the association. Now you can move the blocking to the vertex to the corresponding curve. Now we need to adjust the location of these vertices by set location command and modify the x and z coordinates. For the last one, now display surfaces again. For these vertices, you can select any vertex on this line and modify the y and z coordinates for these two vertices, and similarly for the second pair of vertices here. Apply. Now show the surfaces and hide the fluid pipe 1 and 2 and show the fluid pipe solid pipe 1 and 2. Change the view to the wireframe. Again go to the association panel and here choose the snap vertices and choose these four vertices to be snapped to the pipe. So done. Now turn off the surfaces and split the blocks at the two locations, but the method here is the relative 50% location and one horizontal, sorry, on the vertical edges one should be here and one split should be over here. We have the corresponding points. You can just project them to the, or you can just use this command, the snap vertices, to project them to the corresponding location. Alright, so we need to adjust some blocking here also. So choose this vertex and modify the x and y for these two vertices. Choose this vertex and try to modify them if they can. Yes, they have the modification. And the next one over here. For the next one, now this set of the vertices, Okay, now you can again display surfaces and snap the vertices to the corresponding surfaces here also. Okay, you can adjust this vertex by just modifying the X and Z location, or maybe adjust X location. In fact, it's C location only, or maybe a somehow maybe a Y. Okay, check the premesh. Okay, now go to the split block command and here choose the creation of the OGIRT. Choose all the blocks here and choose faces on the outermost boundaries, which are the inlets and the outlets. Click on apply, and now again go and split the block approximately at this location corresponding to the this curve, and using index control just display the block, the edges which are on this curve, and now associate these edges to the curve here. Also on this curve which is in the green color. And then on the next side, and use the command snap vertices to snap the vertex to the corresponding curves. Alright, now again use index control. Okay, now we will change the material of this block, these blocks to the solid. So right click on the parts and create a new part and call this one as a solid, and choose option which is here, that is to define the blocking material or create part from the blocks. So choose all the blocks over here. They will change the color to the some other color. Now reset the blocking, turn off the blocking visibility and show the pre-mesh. You can adjust the mesh parameters from here, just update the sizes. You can increase the number of nodes in the diagonal edges if needed, maybe 6 nodes. Here maybe 10 nodes, and then right click on pre-mesh and recompute. So we have the problem in this region. Okay, so this needs to be corrected. Now just hide the solid pipe 1 and 2 so that we can see that the whether we have the problem on this sides or not. So just hide the solid pipe 1 and the solid pipe 2. So as you can see, we don't have any problem over here. They are perfectly defined. So only problem is on the blocking on the solid pipe 1 and 2. So hide the solid pipe 1 and 2, display these two pipes, turn off the pre-mesh, and in the index control just display the edges which are on the top side of the this T junction. And now go to the association panel and use this option which is over here, that is to associate the face to the surface. Choose these all faces and associate them to the solid pipe 1, this part, solid pipe 1. So just confirm by middle mouse button and choose the solid pipe 1, and then repeat this process for the faces on vertical pipe, which is solid pipe 2 here, and then check the pre-mesh. This seems okay, and the quality also is showing the 0.671, which shows that the no problem is there. You can show all the parts. And if you want to see that what is happening inside this mesh, you can use the scan planes. This is how the blocking looks like inside this geometry. Perfect squares almost. If you look at the blocking here, this looks like here. It's a perfect mesh. If we check the angle also, the angle should be a good one value. At least should be greater than the 18 degrees. So 30.96. So it's a good to go, and you can go and get the simulation results for this case very easily. Thank you for watching this tutorial, and if you have any query you can email us at the email ID given in the description. Thank you for watching. Bye bye.